Here we go, stats. Last new lesson of the year. So let's look at how to perform a significance test for a mean of differences, otherwise known as paired data. So we actually started off this week with the confidence interval for paired data, but now we're going to do our significance test for paired data. But of course, it starts off basically the same way. Now we're going to use the same situation, the memory strategies. And I give you a couple of statistics here. So we do the same memory strategy. There were 32 seniors who did this. And the mean of the differences is X bar over here. The standard deviation of the differences is here. And we want the 0.05 significance level. All right, so again, starts off exactly the same way. What is our parameter? It's always a true something. Now remember, for paired data, how many means do we have? We only have one mean because we take several differences, and that even though we have, two parts of the experiment, we take the differences from each part and average those. So there's only one mean, and this is the true mean difference. In this case, in words memorized. Using strategy A versus B. Or in this case, it's labeled 1 and 2. You know what? Let me change it back to A and B to keep it consistent. So strategy B and strategy B, strategy A. There we go. Keep it consistent with what we were doing before. Our statistic is our X bar difference, which is given. Our hypotheses, our null, will be that there is no difference between these two. So our mu difference is 0, and our alternative is that there is difference, and specifically we want to know if strategy B improves, which means we remember more words of strategy B. And we're doing B minus A, as you can see here. So if we remember more words with B, then our mu difference is going to be positive. All right, and the significance level is 0.05. All right, the name of the procedure. Now again, remember, even though we did two sets of data, we took the difference and then averaged them, so they became really parts of one set of data. So this is a one sample t-test. We have our same conditions, our random, and I believe I tell you that we have a random selection up here, random selection. So random selection, whoops. All right. Then we can technically say that this was an experiment because I did impose treatments on you, A and B, and those were the only differences in everything. So we can say 10% doesn't apply. I have a feeling with the changes with coronavirus this year, they're not going to care so much though. They'll probably still check 10%, but I don't think they're going to care if you write whether it applies or if it's, in this case, 32 would be less than 10%. And then let's check for normality. Our favorite one is CLT. What was our sample size? Sample size of 32. Wonderful. CLT applies. We have normality. So, 32 greater than or equal to 30. Normal by CLT. My normal looks like a hormel. Let me just fix that. All right. So remember, we can either use a t-test or we can do the work. I'm going to show you the work this time. It's always good to remember where the numbers come from. So our X bar difference was our mean, and that's 1.5. Our standard deviation is our S difference. So the standard deviation of the sample. Oh my God, that looks horrible. Let's fix that. S difference over the square root of n. So in this case, we have 27 over square root of 32, which gives us 0.477. All right, we have a t-score, which we take our mean, 1.5, subtract our assumed mean, and let me fix that 1.5 first. 1.5. Our assumed mean is our mu difference, so that's 0. And we divide by the number we just got, 0.477. That will give us our test statistic, 3.142. Gonna draw a picture. So our test statistic, 3.142, that's 3.14 standard deviations, which is all the way out to the right, somewhere over here. So we'll shade in that part. 0's in the middle, our assumed mean, and then 1.5 is where that shaded section starts. All right, just because we're doing this by hand doesn't mean we can't have some calculator help, so we will have our TCDF. Our lowers is the 3.142, or our T. Our upper, whatever, some big number. And our degrees of freedom for this case is 31. And remember to label lower, upper, degrees of freedom. And what does this equal? 0.0008. There we go. Sorry, 0.0018. Misread my handwriting. All right, so now we have our p-value, and 0.0018 is less than our significance level, so of course we reject the hoe. We have convincing evidence. And don't forget about context. You don't just stop there. We have convincing evidence that what? Remember, you can copy from the question here. So this whole section, we have convincing evidence that we don't even need the significance level. Strategy B improves memory. So I'll just erase this part. And we'll add this to our line. All right, so I actually have the beginnings of your big ideas over here. Paired data, remember, is a one sample t-test, and there is our formula to get our t-score. But I want to focus on whether we should use one sample or two sample, because usually with differences we use two samples. But for a paired data, even though there's a difference, we use a one sample. So let's get clear on when we use one sample versus when we use two samples. So one sample, we use it in this lesson, and that's when we have paired data or matched pairs. You can see either term. So paired data or matched pairs. Oops, that doesn't look like an M. There we go. So that is one case of using one sample. And generally this happens when we subtract and then create an average. So let's write that down. If you subtract and then average, that is a one sample. All right, and also if you're ever only given one mean, of course, if there's one mean, it's only one sample. Versus two samples. If you have two means, then that is a two sample test or two sample interval. And the other time when this would happen is if you average and then you subtract. So you find an average, then subtract. That would come from two samples, and therefore it would be a two sample test or confidence interval. So in the workshop actually are some questions that help you practice one sample versus two samples. So this is a really short workshop. There are 3 different situations. You have to explain whether this is a one sample test or one sample procedure versus a 2 sample procedure and how you know. So please make sure you do these 3 questions and then you have your textbook. Please also remember that you have a quiz on Monday. Your quiz is on lessons 7.1 through 7.4. So that is confidence intervals for any means, whether it's a paired means, difference of means, just one mean. That is lesson 7.1 to 7.4. So please make sure you study for your quiz. It will be on AP Classroom. Please make sure you can access your AP Classroom page. If you run into any technical issues, please let me know because I need you to be able to access it to take the quiz. And please look at Google Classroom for more details. I already made a post up there. All right, email me over the weekend, though I recommend if you can take a little bit of a break. Otherwise, I will see you soon, I hope.